One of the other applications of matrices is being able to solve systems of equations. So today what I want you to be able to do is to find the determinants of a 2 by 2 and a 3 by 3 matrix. I also want you to be able to use Cramer's rule to solve systems of linear equations. So let's first define a few things. A square matrix is a matrix with the same number of rows and columns. A determinant is a value associated with a square matrix. And to distinguish matrices from determinants, you want to look at the brackets that enclose them. So a matrix is enclosed by brackets. A determinant is enclosed by something that looks like an absolute value, but it's not an absolute value. It just kind of has the same appearance. When using determinants, matrix A may be denoted as, if we want to find the determinant, it can be noted as determinant of A, or you can put A right inside the symbols for determinants. So right around the A. Do not confuse determinants with absolute value. So even though they look like absolute value, they mean something very different. Okay, now we want to talk about the coefficient matrix. When you're solving or finding determinants, you always have to put the equations in standard form. So they need to say ax plus by equals c. This is going to be a constant. So the x and the y go on the left, the constant goes on the right. And the way that you find the coefficient matrix is you look on the left-hand side of the equation and just enter these values. So we want A1, B1, and then A2, B2. Okay, very easy to find the determinant. As long as you can multiply and subtract, you can find the determinant of a matrix. So we want to find the determinant of a 2 by 2 matrix. Here's the formula. We multiply on a diagonal, and then we subtract in between. So it's A times D minus, now be careful, when we were multiplying matrices, we added the products together. When you're doing the determinant, you subtract the products. Okay, so now we are going to multiply on a diagonal. So negative 3 times negative 6 is going to give us 18. And then we're going to subtract. Always write down the subtraction sign, because sometimes the next number is going to be negative, and you may forget that you are subtracting a negative. So make sure you write down that minus sign. And then we're going to multiply on a diagonal here. So that's going to be minus 4. And that's going to be 14. So that's your determinant. Okay, I just want to remind you that when you have two lines that intersect, when you have a system of two linear equations, one of three things can happen. The determinant may not be 0 or may not equal 0, and then the system is consistent and has one unique solution. So it would look like this. If the determinant does equal 0, and, so both of these conditions have to be met, at least one numerator determinant is 0, the system is dependent, and has infinite number of solutions. And we can just cross this off here. So these are both consistent. This one is dependent, so we're going to put consistent and dependent. Or sorry, consistent independent, because it's 1. The next one is dependent. So this is consistent independent, and this is consistent dependent. If the denominator, if the determinant is 0 and neither numerator determinant is 0, the system is inconsistent and has no solution. Okay, so you want to keep all of those in mind. Most of the time, you're going to have the problems that we're doing are going to be consistent and independent, so the denominator is not going to equal 0, or the determinant, I should say. Sorry. Determinant is not going to equal 0. Okay, let's look at the next page, and we are going to use what's called Cramer's rule to solve a system. Now, before you use substitution and elimination, we're going to do the same thing with Cramer's rule using matrices. So what we're going to do first is you have to write the equations in standard form. So ax plus by equals c. You want to write the coefficient matrix of the system, then find the determinant of the coefficient matrix, and then you're going to solve for x and y using Cramer's rule, and you're going to divide by the determinant. Okay, so let's see what happens here. The first thing we're going to do is find the determinant. Now the determinant, so we're going to put determinant here. It's going to be the denominator for x and y. Okay, so the way that we find the determinant, we only use the left-hand side here, and we just write the coefficients in. So I have 1, negative 1, so 1, negative 1, and then 3, negative 2. That means it's the determinant. Now I'm going to cross or multiply on a diagonal here. That's going to give me negative 2. Always subtract in between, and then multiply on this diagonal, which is negative 3. So that's one reason why I told you always write down the minus sign, because this is minus a negative. And negative 2 minus a negative 3 is going to give me 1. Okay, now I'm going to figure out what x is. Okay, now what's going to happen here, I am going to call, and you probably won't see this in a textbook anywhere, but I'm going to call these values right here fillers. That's really not what they're called, but that's what I call them. Okay, so we need to, when we're using Cramer's rule, we have a numerator and a denominator. The denominator is going to be this value right here. The numerator is going to be found by, if I'm looking for x, let's just pretend like we don't know what x is. So I'm not going to use these values right here. We're always going to put the x values here and the y values here. They're going to be vertical. So y has a negative 1 coefficient here for the first one, and it has a negative 2 coefficient here. Since we're looking for x, we're not going to put these values in for x, we're going to put the fillers in. So that would be 1 and 4. Now we're going to multiply in a diagonal. Negative 2 minus, and then you're going to write down that minus 4. So that's going to equal negative 2 plus 4 is going to be 2. And I have to put this in the denominator. Now, it's not always going to equal 1, so always make sure that you put the coefficient matrix in for the denominator. So this is 2 over 1, or 2. Now we're going to solve for y. Okay, so we're going to do this. Remember, you're going to always put the x here, always put the y here. Whichever one you're solving for, though, you're going to put a filler in for. So we're going to look here. The coefficient for the x is 1 in the first row. It's 3 in the second row. And now I'm going to put these fillers in because I'm solving for y. So 1 and 4 go here. And now I'm going to multiply on a diagonal. So that's going to be 4. Write down a minus sign. And then multiply on a diagonal here. And that's going to be 3 times 1. So that'll be 3. So we have 1. And we have to put that over the determinant for the coefficient matrix. So you'll always have a numerator and a denominator. Numerator and a denominator. So this is going to equal 1. And your ordered pair would be 2, 1. Okay, you have a you try it to do.